Okay, back for quiz 4 or 5, whatever this technically is. Let's just go with 5. Anyway, our first question gives us two regions and then tells us that the combined double integral of both of them is going to be the double integral of R1 plus the double integral of R2. So let's check out the region and see if that's correct. Let's just draw a graph here. Y, X. 1, 2, 3, 4. Alright, so the problem tells us that R1 is in between X is 0 and 2, and Y is between 0 and 1. So let's check out the X. X starts at 0 here, and then moves on to X equals 2 here. And Y starts at 0 as well and moves up to 1. So this would be what this region looks like. Let me just switch colors here. So region 2 tells us that X is between 1 and 3, and Y is again between 0 and 1. So let's map that out. X starts here at X equals 1 and moves on to X equals 3, and then Y starts at 0 again and moves up to 1. So that's what this region looks like. And as you can see, they overlap. So the problem with that here is that according to the rules of double integrals, you're only able to add the volume of two regions to get another full region if they touch each other on the boundaries, not if they overlap, because in that case you're double counting this area in the middle here. So that's why A is false. B. Curves of the form y equals g of x form part of the boundary for a type 1 region in R2. So basically this is true because a type 1 region is integrated by dy first and then dx. So dy dx. And so our first set of limits here are either constants or they're given in the form y equals g of x or whatever, because then that allows us to change any remaining y's we have to x and then integrate by x. So B is correct. Integral r dr d theta is the total area enclosed by the region D in R squared. Yeah, I don't know really what to say to that. That's just like the correct equation. That's just right. D is wrong. It says that to find the average value of a continuous function, we find over a closed and bounded region, we calculate the volume and then multiply the volume over D and then multiply by D. But that's actually wrong. We need to divide by D. So that's why D is incorrect. D is for every integrable function f(x,y), there exists small b, comma, capital V in R such that small b is less than or equal to the integral over dA, which is smaller or less than or equal to V. I mean, that's also obviously true. There's going to be a maximum and a minimum possible volume. And then F, none of above, is wrong.